Hi students, problem number 7. The coefficient of friction between two blocks of masses m1 equal to 2 kg and m2 equal to 5 kg is 0.5. Find the acceleration of each block if the applied force is 21 Newton in the first case, 35 Newton in the second case and 40 Newton in the third case. It's a very interesting numerical problem. Let us solve it now. Now the coefficient of friction between the two surfaces is given as 0.5. The force F is called the driving force. It is directly acting on the second mass 5 kg and no other direct force is acting on the first mass 2 kg. So there will be some friction between the two surfaces. The frictional force, okay, the frictional force F is equal to mu into m1 into g. So this frictional force is acting on this mass 2 kg and the applied force F acting on the 5 kg mass will produce a pseudo force on the 2 kg mass, which is given as F dash. This is the pseudo force and this will be equal to m1 into acceleration A. So actually the driving force F is acting on the second mass. It produces a pseudo force. So what is this pseudo force? It is not a real force. So this is the force which produces a relative motion between the two masses. Okay. So now if this pseudo force F dash is less than or equal to the frictional force, okay, then the two bodies, the two masses will move together. They will move together with the same acceleration. So if the pseudo force is either less than or equal to the frictional force, till that the two masses or the two blocks will be moving together with the constant acceleration. Suppose if F dash, the pseudo force is greater than this frictional force, means then these two masses will have different acceleration. Understand? Now we will take m1. So let us take if F dash is equal to F, so that m1 into A, this is equal to mu into m1 into g. So I told you that this pseudo force either less than or equal to, means this equal to is the value corresponding to the maximum acceleration. Is it not? When the pseudo force is exactly equal to the frictional force acting between the two surfaces, then the acceleration of the 2 kg block, that will be maximum. So cancelling this m1 on both sides, the maximum acceleration is equal to mu into g, that is 0.5 into 10. Therefore, the maximum acceleration, A maximum, is equal to 5 meter per second square. So this is the maximum acceleration. Now for the three cases we are going to deal. So case 1, in the first case, the applied force is equal to 21 Newton. Okay, 21 Newton. So, and the total mass is 5 plus 2 is what? 7 kg. So, this 5 plus 2 into acceleration A is equal to this 21 Newton. So 7A is equal to 21. Therefore, A is equal to 21 divided by 7, that is equal to 3 meter per second square. Since this 3 meters per second square is less than A maximum, so this is less than A maximum. Therefore, the blocks will move together. Okay, so the blocks move together because the acceleration of the system of two masses is less than 5 meter per second square. Therefore, in this case, the acceleration of the first block is equal to the acceleration of the second block, and that is equal to 3 meter per second square. Okay. Now the second case, case 2. So this is the second case where F is equal to 35 Newton. So this is 35 Newton. So once again 5 plus 2, the total mass is 5 kg plus 2 kg into acceleration is equal to 35. 7a is equal to 35. Therefore A is equal to 35 divided by 7 is equal to 5 meter per second square. So this can be the maximum value of the acceleration up to which the two blocks will move together, is it not? Therefore, here also A1 is equal to A2 is equal to 5 meter per second square. Therefore, the two blocks will move together. So 5 meter per second is the critical value, beyond which what will happen? The two blocks will have different acceleration, is it not? So case 3 now. So third case, F is equal to 40 Newton. So 5 kg plus 2 kg into acceleration of the blocks is equal to 40. So 7a is equal to 40. Therefore, a is equal to 40 by 7 is equal to 5.7 meter per second square, which is greater than 5 meter per second square. Now the blocks cannot have the same acceleration. They cannot move together, is it not? One is going to slide over the other. Let us find out the individual accelerations. Okay. Now for individual acceleration, you can look at the 2 kg block. There is no direct force acting on the body. See here. So this is the 2 kg block. For the 2 kg block, the driving force is the frictional force. Okay, so this is the frictional force. So the frictional force F is equal to what? Mu into M1 into G. So this is the driving force. And this driving force is now equal to 0.5 into 2 into 10. So this is equal to 5. So 5 into 2. So this is 0.5 into 10 is 5. 5 into 2 is 10 only. So 10 Newton is the force which is driving the 2 kg mass. Therefore, the acceleration A1, acceleration of the block must be equal to this driving force 10 Newton divided by its mass, and this is equal to what? 5 meter per second square. Understand? Now, what is that for the second block? For the second block, you can see here, this is the second block. Actual driving force is F and the opposing force is this frictional force. So, the second block, if you take, this is the 5 kg block. Okay. So, for this, here, this is 40 Newton is acting forward, and this 10 Newton is acting up. This is between the two surfaces. Okay. So, only if I consider the mass of 5 kg means 40 Newton is acting forward and 10 Newton is reverse. Therefore, 40 minus 10. 40 minus 10 is equal to 5 into A. So, this implies 5 into A is equal to 40 minus 30 is 40 minus 10 is 30. Therefore, the acceleration of the second block, A2 is equal to 30 by 5, that is equal to 6 meter per second square. So now the blocks are having different accelerations, isn't it? So now what is the relative acceleration? Relative acceleration. See, when the acceleration of the two blocks are different means now I can say that they have a relative motion. Understand? And the acceleration of one body with respect to the other body. I will take acceleration of the first body with respect to the second body. This is called the relative acceleration of the first block with respect to the second. So this must be equal to what? 5 minus 6, that is equal to minus 1 meter per second square. Okay, we get a negative value for what? This relative acceleration of the first block. So when we pull this 5 kg block with a force of 40 Newton, what is going to happen? the 2 kg block will move in the opposite direction, in a direction opposite to the applied force with an acceleration of 1 meter per second square. Understand? So now M1 will move backward. M1 will move backward. Backward means it is moving in a direction opposite to the direction of the applied force of 40 Newton. So my dear students, in this first we started with the pseudo force created by the driving force. This pseudo force may be equal to the frictional force or less or greater also. So if the pseudo force produced by the driving force is either less than or equal to the frictional force, the two blocks will move together. If the pseudo force exceeds the frictional force, means then they will have different acceleration. One will slide over the other. So in the three different cases, we have found that in the first two cases, the accelerations of both the blocks were equal. So they were moving together. But in the third case, they have different accelerations. So they cannot move together. And the first block of mass 2 kg is sliding over the second mass with an acceleration of 1 meter per second square in the backward direction. I hope you must have understood well. Fine.